simplify square roots and radical expressions. These are your list of perfect squares that you're going to need to be thinking about as you reduce your radical. So there's a list if you want to copy it down. We're going to look at 45 and think about what perfect square would go into 45. And that would be a 9 times 5. And so what I like to do is pull out close to the end of the radical the perfect square that's going to come out. And so when we do the square root of 9, we're going to get 3. And then this 5 will stay under the radical. Let me show you some others. 8. 8 is not a perfect square, so we look at our list. We'll quickly see that 4 goes into 8 2 times. And then I'm going to take the square root of 4 and get 2. But this 2 is stuck under the radical. So it's 2 on the square root of 2. 75, you look at your list, it's not a perfect square, so you're going to start looking through the list. Which number will go into 75? I always try to get the highest, biggest perfect square that'll go into it, and 25 will go into 75. So we're going to do 25 here times 3. So we can do the square root of 25 and get 5. And then you'll have a 3 left over. So that's how you handle the numbers that are under radical. Now I'm going to show you how to handle variables that are raised to an exponent. First one I want to look at is the square root of 4, x to the 16th, y to the 5th. If you look at this, think about an index. When we say square root, an index of 2 over here. That's going to help whenever we do our variables. Quickly, we can see that 4 is perfect square, so it's going to be coming out, so I'm going to put it here. Whenever you have an exponent, you're actually going to take that exponent and divide it by the index, which is 2. So that will come out cleanly, so we can say that all of this, x to the 16th, is going to come out. We have an issue with y to the 5th, because 5 is not divisible by 2. So we're going to have to split up y to the 5th in such a way that we can get almost everything out. And so you're going to think about y to the 4th times y. That's the same thing as y to the 5th. This will come out completely, so we just need to reduce all that down. So the square root of 4, 2, you have to do this. X to the 16th, when you take the square root of it, you're actually taking 16 divided by 2. So you're going to get x to the 8th. And then y to the 2nd. And then you have a y left over. Okay? The next one. Square root of 5. When you look at 5, there's not even perfect squares that will divide into it. So 5 is going to be stuck under the radical. So I'm going to go ahead and put it towards the back. A to the 6th will come completely out, because it's even. So I'll put it up here in the front. And then the b to the 7th, we're going to have to split it up. And you want to split it up with the highest even, which would be b to the 6th, and then times b. So when you take the square root of these, you're going to do 6 divided by 2. So you're going to have a to the 3rd, b to the 3rd, and then 5b will be left over. Let's do one more. 18. 18 is not on that list of perfect squares, but there is a perfect square that will go into 18, and that would be 9 times 2. So I'm going to split it up like this. 2 is going to be stuck inside under the radical, so I'll put it in the back, but the 9's coming out. X to the 2nd is even. It's coming out. And y to the 8th is even, so it's coming out. So both of those get put in the front. Now, we just simplify the front stuff. So the square root of 9 is 3. X to the 1st power, and y to the 4th power, and you still have that 2 left over. I do need to bring your attention to when you work on the variables with exponents, you got to pay attention to this rule. If you start with an even exponent under the radical, like this, 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 or this, but when you do your simplifying and you end up with an odd exponent as the answer, you have to put an absolute value around the variable. So let's underline that in our notes. So if it starts even, but ends up odd, okay, make sure you make note of that. So let's go back to our answers. So we need to look at x. So it started even, but it ended even. So it's in good shape. You don't have to have any absolute values. a to the 6th. It ended up odd. So you're going to come back and put an absolute value around a to the 3rd. Okay? The x to the 2nd started even, but ended odd. So we got to put an absolute value on the x. Okay? And one last thing I need to tell you about. You cannot leave a radical in the denominator. So make sure, I wrote it in red, make sure you underline, put stars by it, highlight it. That's a big deal. So we have to, we're going to do what's called simplifying, but we are rationalizing the denominator. We have a way of getting around this by multiplying the top and bottom of this fraction by the square root of 3. Let me show you what happens when you do that. But you have to do the top and the bottom, because this is actually equal to 1, so you're not really changing the actual value of this fraction. It's legal. But what happens here, let's pay attention to the denominator on this. The square root of 3 times the square root of 3 is the square root of 9, but it actually will turn into a 3, which is no longer going to have a radical in the denominator. The top is the square root of 30. So take a minute, think about all your perfect squares. Is there a perfect square that will go into 30? No, so it's going to be left like this. Let me tell you right now, you cannot reduce these two. Anything that's under the radical cannot relate back to a number that's not under the radical. So those two are actually unsimplified.